Okay, so chapter 4 is going to be our first chapter of entirely new things. Okay, so chapter 1, chapter 2, chapter 3, we did have some new things, but you had some things you had in Algebra 1. It was like a mix of old and new. Chapter 4 is entirely new. There's nothing in chapter 4 that you know how to do. It's entirely new learning. This isn't the break point in the year where it's like that forever. Okay, chapter 5, 6 is a mix. Chapter 7 is a little bit of a mix, but it's more new than old. But chapter 4 is all new. So what chapter 4 is about is a thing called systems of equations. So I like this chapter. I enjoy doing these. I don't know if you're going to enjoy doing them, but I'm upbeat on this chapter. I enjoy doing these problems. But what makes something be a system of equations is you have more than one equation at a time, and there's more than one variable at a time. Okay, so last chapter, everything we looked at had x's and y's pretty much. Okay, so to see two variables isn't new, but you only dealt with one equation like that at a time. Okay, this chapter we're going to deal with two or more equations at a time, two or more variables at a time. Today it's all 2x2 systems. Okay, by 2x2 system I mean there's two equations and there's two variables. That's a 2x2 system. We'll work our way into 3x3s eventually. I think for extra credit at some point I give you a 4x4, but we never do a 4x4 for real points. Okay, but that's the transition point. Okay, there's a thing called systems of equations, more than one equation, more than one variable. So let's build up some momentum from things we know. If I give you just an equation like this, which we've seen this one before, the first day I brought into chapter 3, I think we broke this one out. Can somebody give me an ordered pair that makes this work? 2, 3 works. 3, 2 works. 1, 4 works. 4, 1 works. 0, 5 works. 5, 0 works. I think the first day I threw that up in chapter 3, I even got into some negatives, I got into some decimals or fractions. If I wanted all the answers, that's cruel. Why is it cruel if I said, list me all the ordered pairs that work? There's a ton. There's how many? What's it called, that number? It's an I word. There's an infinite amount of solutions. It never ends. You go literally forever listing them on the board. And I explained to you, there's only one math tool that can show you all those answers at once. What's the one math tool that can show you all those answers at once that we did last chapter a lot? Graphing. Graphing is like the only way you have right now that can show you all of those answers in one swoop. But there's an endless amount of answers. For me to transition into this chapter and have a system of equations, I have the foundation there with one of them. I just need to drop you in another equation. So if I say, oh, by the way, 3x plus 2y equals 11, I could sit here and for all eternity come up with an endless amount of answers for this also. Okay. Anybody have a theory on how you would find an answer to the system? What would have to be true? It has to work for all the equations. Okay. So to find a solution, it has to work for everybody, both levels. Okay. So out of these 6, you did luck your way into the one that will work for this also. Can anybody spot which one of our 6 also will make this true? One, 4. If we do 1 here, 3 times 1 is 3. 2 times 4 is 8. 3 plus 8 is 11. 1, 4 is the only solution for this that will also work for that. That's not going to be the way we'll do these all chapter. Okay, we're not just going to like write all the possible solutions for one and then hope we find our way into one that works for the other one. There will be 3 ways that we can solve these systems of equations that we're going to learn. 1 today, and we'll go 2 more on Monday. But again, to be a solution, the answer has to work in all of the equations. Another important fact to just be aware of, if we are going to set about trying to find a single solution and not find an endless amount of solutions, for us to even try to chase a single solution, the number of equations has to be greater or equal to the number of variables. So if you have two variables, you need to have two equations or more. If there were 5 variables, to solve that and get this is the answer, you would need to have 5 equations or maybe more. Okay? But we need the number of equations to at least match or maybe beat the number of variables for us to even try. So if you ever saw 5 variables and only 3 equations, don't even try. It's hopeless. You can't do it. Okay? But that's 3 main ideas of this chapter. We're going to always have more than one equation and more than one variable and work together. To even be worthwhile trying, the number of equations has to be at least as big as the variable count. And to be a solution, it has to work everywhere, at every level, in all of the equations. So the first bit of homework, they'll give you a system, and they'll give you something to try and see if it works. So as always, first number goes in for x, second number goes in for y. So if we plug in the 3 and the 1, does that work here? Yes. I should not immediately just go yes and move on, because before I can commit to yes, it has to try the other one also. So if we try 3 here and 1 there, are we still saying yes, or did that one bomb out? We're still saying yes. That one is a yes. How about 2, 2? We look here, 2, 2? Yeah. So we just say yes and move on? No. Try it there. No. It doesn't make 11. What did it make? 10. So close, but no. Okay, so that's homework possibility 1 is just does it work? Yes or no? Plug them in, try it out. But to say yes, you've got to try it at every level. It has to work at every level. Question about the yes, no, does it work, sort of problems on these. There's 8 of those. 1 to 8, yes, no. We're trying them out. I'm looking at 162 is where the homework will go. Question there? Here's how we're going to solve these today is tap into our knowledge from last chapter. We just said a minute ago that this equation has endless possibilities. The only way we can describe them all is to make a graph. This other equation also has endless possibilities. We could also there make a graph. If we go ahead and graph 2 equations, what shape would these both be? Lines. What's the rule for lines that we just had on the test yesterday? Not allowed to have variables on the bottom. Do we see anything like that today? Nope. What else aren't we allowed? Variables with powers. Do you see any of those? Nope. What else? Variables multiplying other variables. Do you see those? Nope. So everybody's aligned. Okay, this section, everybody's aligned. When we get into chapter 10, not everybody will be aligned, and we may try to tackle this again with things that aren't all aligned. But today, everybody's aligned. So today, if we're gonna try to solve these graphically. So today's job, solve by graphing. There's 3 scenarios that could come up. If everybody's aligned, and I hit you with 2 equations, use your arms if you want to communicate. There's 3 scenarios that could happen in terms of what your graph is going to look like once you do line number 1 and you do line number 2. You could be looking at 3 different types of scenarios of pictures. What's one thing that your picture could be? Could be parallel lines. So you could do line 1 that looks like this. You could do line 2 looks like that. That's going to have scenario number 1, a certain type of solution. What could be scenario number 2? Perpendicular is like a sub-choice of another choice, but that's in there. It's intersecting, so they can touch each other. Whether they're perpendicular or not, when they touch each other, it's just going to kind of look like an X. So X marks the spot kind of stuff. That's a scenario you could have. And then there's a third kind of weird scenario. If they just stacked on top of each other. You might do line number 1 on your graph paper, and then when you go to do line number 2, it just stacks right on top of line number 1. Does anybody have a thought, once we're looking at these 2 lines, of where we would look for how is the answer found? Where is the answer?
just the start and the end of the line?
Not necessarily. So line number 1 shows you all the answers for one. Line number 2 shows you all the answers for the other one. To be an answer for the total problem, it has to work everywhere. So on the graph, how would that show itself?
It's UAJ.
What do you say?
Would it be it stacking?
Say again?
Would it be it stacking?
Yeah, like where they touched each other. Okay, so all the solutions for one line go here, all the solutions for the other line go somewhere else. Where they're going to touch each other would be where the solution actually exists. So something like this, how many answers would something like this have? This has one answer. And that's what's going to happen to you today, every problem. Every problem, the graphs will make an X, it'll have one answer, X marks the spot, where they touch, that's the answer. What would this do? It has no answer. That's going to happen to you later in the chapter at some point. This would have an infinite amount of answers. That's going to happen to us later in the chapter. But we're not worried today. Today there are no stacking lines to be an infinite amount of answers. There are no parallel lines to make you with no answers. Although one of the graphs might be close, I feel like on one of the graphs you might have a thing like this and a thing like that. I think happens once on the homework. If you graph in like your normal 0, 1, 2 kind of spots, I think you're going to get lines like this that you might look at and think, well, those don't touch. And I would say, yes, they do. Okay. Why am I saying yes, they do? Because how far do lines go? They go on forever. So if you keep drawing this one a little farther, and you keep drawing this one a little farther, sooner or later they're going to touch. Okay. I think one of the graphs on the homework does that. I'm not positive, but I think so, if I remember this from, it's been 2 years since I did this subject. But, in the homework tonight, for sure, they'll all touch, guaranteed. Question about the idea? So I'm going to need probably camera rotated while I stroll down the lines. When you go to graph the lines, it doesn't matter how you graph the lines. So from yesterday's test, sometimes, how did some people graph some stuff yesterday? Make a table. Yeah, so yesterday some people were making tables all over their test. If you like making tables, you can make tables. Some people don't like making tables. You don't have to make any tables. Sometimes the table's the way to go, sometimes it isn't. But if you look at your lines and you're like, I want to make a table for that, make a table for that. That's fine. She also said slope-intercept form. Slope-intercept form is a thing that you can do to get these graphed. What does slope-intercept form mean again? Y equals. So out of A, B, C, and D, do you see any that would be like real easy to get Y equals? I'd say B is medium. I mean, let's do it. If we go to get B, Y equals, what would we do?
-6.
Okay, we go ahead and subtract the 6. So 2y weights, 4x minus 6 gets invented. Y equals 2x minus 3. That's fine. We can do that. That wasn't too bad, but I'd say that was medium difficulty. There's an easier one than that. D. Okay, if we get dy equals 6 minus the x, that's probably easier. If you want to make everybody y equals, could we make everybody y equals? Yeah, that's fine. Could you do everybody as a table? Sure, that's fine. What's the third choice that we can use to graph other than y equals, other than making tables?
Intercepts.
Intercepts. Okay, is this one well set for intercepts?
Yeah.
I'd say yeah. If we're in, what's this form? Standard form. And if these numbers can divide, that's ready-made for intercepts. So this is telling me x is 0. I cover up x with my hand, and I mentally undo that one with an opposite, get 2. If y is 0, I solve for x, I get 4. How you graph the line doesn't matter. Table, intercepts, slope-intercept, I don't care. No one cares. Just graph the line. No matter what process you use, the line's going to end up in the same place. So you could have 3 people do 3 different ways to graph this, We have intercepts, we could have done y equals, we could have done a table, but the line's gonna go the same place no matter what. You look at each individual line, and personally, I mix and match. Okay, I like to do intercepts when I can. I like to do slope-intercept form when I can, and I try to never make tables. That's what I do. But if you want to make tables, whatever, I don't care. But just because you do within a system one equation one way, you don't have to do the other equation that way. Every line stands on its own. But 0, 2, where would 0, 2 go? Up 2. Where is 4, 0? Right 4. You want to be straight today, okay? So absolute mandatory graph paper usage and highly suggested ruler usage, because the whole goal is to see where these lines are going to cross, and if you draw crooked, that's going to be tough. Okay? I don't have a handy ruler, so I'm going to try to just go as straight as I can, and that's not too bad. How do we graph using slope-intercept form? We got this y equals. Where are we headed on this?
Down 3.
Down 3 to make a dot.
Up 2, right 1.
Up 2, right 1. And then we could go up 2, right 1 again. We'd be over there somewhere. And then play connect the dots. And I feel like I've got some sort of a flaw in something that I did. Because most of the time, these are going to cross at squares, corners, and I don't like where this is. Like, where I am is like 1.5 and 1, and I'm thinking I copied a problem wrong or something.
So most of the homework is gonna be on like a corner.
They are most of the time going to be on a corner, yeah. No, I didn't copy anything wrong, I just didn't draw very well. So again, I gave you this talk last chapter. My board is never going to go quite right for me, and my issue, I think, is this should be the same size as every other square. So like that should be the same as this, should be the same as that, and I don't think they are. So I think I've got a little bit of crookedness here. So that's unfortunate. But on the homework, they're going to hit corners of graphs. The closest corner we'd be is probably like to there, but I'm off. But 2, 1 is what I'm thinking we should hit. My apologies for my graph. If I had graph paper, I promise it would have just worked a little better. But tonight, for sure, graph paper and rulers. 90% of them are going to clip corners. I'll look at that in a second and confirm that, but 90% of them should be hitting corners. We did some graphing. We still have some uncertainty because that still doesn't look right. How could we know if we're right or not?
Plug it in.
Plug it in. So 2 times 2 plus 4 times 1, is that 8? Yes. 2 times the 1, is that the result of 4 times 2, subtracting 6? 4 times 2 makes 8, subtracting 6 is 2. 2 times 1 is 2. That does check. That is right. We are good. Question about how that went? Hopefully the next one grows a little better on the graph. Am I still good on the viewfinder there? Good. Okay, so this one, could I have done intercepts if I wanted to?
Yeah.
Yeah. If x were 0, y is 6. If y is 0, x is 6. So if we wanted to graph this with intercepts, we'd go an over 6 and we'd go an up 6. What if I wanted to graph from slope-intercept form? Which number would I have done first?
The 6.
The 6. And then the slope of -1 would take you down 1 and right 1. Down 1, right 1. It's going to keep coming down 1, right 1, all the way down. And I don't know if that's gonna be straight enough or not, but it's my best attempt. Graph paper and ruler would solve any issues that hopefully don't present themselves. Question about how to graph that, either by intercepts or slope intercept, or however you graph it, you graph it. This one, is the intercepts gonna work?
Yeah.
Probably not, because if you divide 2 into 3, it's going to create fractions, and we're going to try to avoid fraction graphing. So what do you want to do about that?
Add
Add the,
x to the other side.
yeah, so I got 3
Minus 2x.
close
Plus 2x.
plus 2x. So to do opposite of minus 2x, I can add the 2x out of there. If I go to get it completely y equals 1 plus the 2/3 x. I agree. So where would that graph start?
Right.
Up one.
Up 1 for that plus 1. And where will the 2/3 guide us?
Up to right 3.
Up to right 3. And that worked out real nice because that was already a landing point that I had found earlier. When I kept going down 1, right 1, I landed there. When I'm up 2, right 3, I landed there. So this line goes like that. Score 1 for my homemade graph paper this time at work. Where am I? I'm at 3, 3. Because I moved over 3, up 3, that's where we are. Probably. Graph's always uncertainty, so I would always recommend that you plug in and check. Does 3 plus 3 make 6?
Yeah.
Yes. Does 3 times 3 minus 2 times 3 make 3? Yes. So we can confidently move about our business. Okay, that's the tonight homework scheme. Graph every line, graph every other line. They're all going to make X's. They're all going to cross. We hope they land in corners. They usually do. If they don't land in corners, it gets a little more awkward. But then we just try to guesstimate it. Question about where we are. Let me stroll back to my book and take a look. And other things that rhyme. So like I said, we're on 162 for this homework. We're on 162 for 2 days. If you peek ahead, you can see Monday we're going to learn a thing called the substitution method where we can avoid the graph. We can do addition method where we can avoid the graph. We already saw some reasons today why graphing isn't so great. Talk more about that on Monday. But 1 to 8 is going to be just yes, no, based on plug it in. It has to work everywhere to say yes.
Wait, what page?
162. So 162, 1 to 8, you're either saying yes or no based on working everywhere. Since it has to work everywhere, you'd kind of expect you'd probably more often say yes or more often say no.
Yeah.
No.
More often say no. Why more often would you think say no? It has to work everywhere, so it's hard to say yes. It's got to work for everybody. So there are more no's than yeses on the 1 to 8. 9 to 20 is like what we did on the board where we're needing to graph. We're going to need to do some X's. The graphs will make X's, and then we see where we cross. So let's see, there's 12 problems, so there's 24 possible numbers. Every answer has an ordered pair. So if you get 12 pairs, that's 24 values. 2 of them are going to be fractions, but they're going to be halves. It is possible with graph paper and rulers, if you're at like 1.5, 2.5, 3.5, you can notice the halves, okay? So if you don't land on a perfect corner twice, it is something to do with a half. The other 22 answers should land on perfect corners. Okay, so 22 out of 24 numbers are whole numbers. There's nothing bigger in value than 7. Okay, so if you ever find yourself with your touch point more than 7 away from the origin, you've gone way too far on your graph. The maximum number is 7. Maybe it's positive 7, maybe it's negative 7, but 7's our highest number. The second place number, there's 1, 5. And then the third place number, there are a couple of 4s. Okay, but most of the graphs should be within 4 of the origin. But one time touch at 7, one time touch at a 5, a couple times touch at 4, 3, 2, 1s, 0s. But again, 2 of them will be halves, the rest of them should hit perfect corners all the time. Ruling on this, when I grade it, I've got like a transparency that I'll lay on top of graph papers just to check stuff. I don't demand perfection, but I will demand that you get half of them right. 12. So there's 12 of those. So you're going to need to have 6 correct graphs. So if some of your graphs go screwy, if you can't get the ones with the halves, like life goes on, I won't demand perfection. But you need 6 X's to go in 6 right spots out of the 12 questions. So just be careful you're getting your graphs in the right spots. I would not, if you do the first maybe like 2 or 3 and it isn't working, you might want to just call timeout and re-strategize, because you don't want to waste your time doing like 12 problems wrong and me show up and be like, yeah, you need to do those again. But check them in the back, check them by plugging in. If things are working, things are working. But that's a requirement on 162, is get like half of these to play out to be the lines in the right spots, which should be doable. As I graded your tests yesterday, your line graphs were pretty good. The lines are better than the U's, V's, and steps, although the U's, V's, and steps were decent too. But we're pretty good at getting our lines in the right spots, so that this should be doable. Just use graph paper, be careful. Anybody question 162, anything about what we're trying to do with this for our Monday life? Okay, so we can shut that one down.